Hello guys, my name is Desmond and I welcome you to my YouTube channel. Guys, as you can see, for today's lesson I'll actually be covering uh, information for grade 8, 9, 10, 11 and 12. So I'm just quickly going to go through the basic rules of mathematics. So just before I get started, I would like to just indicate that this lesson was suggested by a lady called Lizzie Shiburi. That was because she had a grade 9 learner who actually suggested to have this lesson. So today's lesson is actually dedicated to all the parents who are assisting their children with their maths related homeworks, questions, or assignments. So guys, what I'm hoping to achieve by the end of this lesson is to explain to you all the basic rules from number 1 up until number 7, and also make use of this information to explain to you what examiners normally use in order to derive equations. So before I go any further, guys, please do make sure to subscribe and again hit the bell notification so that you're notified of future uploads. So what I'm quickly going to do is to go through all of this information that I've written down, and then from there I should be able to make use of relevant examples so that you fully understand what the basic rules assist us in terms of approaching maths related questions. So guys, you just need a notepad, a pen and a calculator, and most importantly a glass of water. So I would advise you to just watch the video and listen without having to write anything. I'll make sure to have this lesson available as soon as we are done with this lesson, so that you can be able to replay it over and over again until you're able to make the notes for yourself. So we've got basic rule number 1. So what I've written there is a to the power 0 is equals to 1. Rule number 2, it's a to the exponent 1 it's equals to a. Rule number 3, we've got a to the exponent m multiplied by a to the exponent n, which is equals to a to the exponent m plus n. So guys, remember, to the exponent and to the power, it refers to one and the same thing. So from time to time, I'll just refer to the exponent, and again, I might be saying to the power. Just know that it refers to one and the same thing. So number 4, I've got a to the power m over a to the exponent n, which is equals to a to the power m minus n. Rule number 5, it's open bracket a to the power m close to the exponent n. It's equals to a to the power m multiplied by n. Rule number 6, open bracket a over b close to the exponent m. It's equals to a to the exponent m over b to the exponent m. And rule number 7, it's a to the exponent negative m. It's equals to 1 over a to the power m. So I'll just leave it there for now. I'll get back to those basic rules with related examples so that we unpack each and every rule. So now, guys, I just want to bring it to your attention that for every maths related question, it could be a simplification, it could be an equation. So they normally use letters to derive equations. So they use letters to form equations, or they use letters to form maths related problems. Letters could be A, B, C, D, up to X, Y, and Z. So they can just pick up any letter to use in order to form a mathematical expression. So they normally mix these letters with numbers. Okay, so I would challenge you to open a maths book and look for any equation which may be given. I can guarantee to you guys that it will be either a number combined with these letters from A up to Z, or it could be just numbers. In some instances, it could also be letters only. So guys, they make use of these signs in order to give the combination of numbers and letters to just to give them a meaning or mathematical meaning. So you've got a positive sign, obviously, is there on your calculator. You've got a minus sign, you've got a multiplication sign, division, these are brackets, this is negative, and this is equal sign, and you've got your square root. So guys, you just need to know that to form a mathematical equation or expression, this is what they use. Letters, they just pick from A up to Z. They can just pick up any letter, and then from there they make use of numbers from 0 up until 9. Remember guys, the numbers that we always see in terms of money, in terms of, it could be a temperature, it could be velocity, whatever that it is the combination of these numbers from 0 up until 9. You won't find any number not having this or one of these numbers. It's just from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means it's 10 numbers that make these big and small numbers. I'll give you an example. Let's say 135. Can you see guys? This is a number which is the combination of 1, 3, and 5. You can also have, let's say, 8,274. Can you see guys? This is a number which is the combination of 8, 2, 7, and 4. So that's why I'm saying we make use of these numbers to give a mathematical meaning, expression, or an equation. So I just used these numbers as an example. So towards the end of this lesson, you should be able to fully understand what I mean by that. Again guys, in terms of combining the numbers and the letters, for example, they can say 2a plus 3b. Okay, in this case, 2 it's a number, 3 it's a number, so 2 is combined by letter A. So you've got the combination of number which is 2 and letter A. Here you've got the combination of 3 and letter B. So both of these are separated by a sign. In this case, it's a positive sign. So that means it's either a positive or a minus sign which separates the terms. So something to note guys, we've got a thing called a term. So a term is separated by a sign of a positive or a sign of minus. So in this case, we've got a positive sign, meaning we've got, this is the first term, this is the second term. So that means we've got 2 terms. Okay, so guys, because A is a letter, B is a letter, that means A and B could be representing something else, and whatever that A is representing, this 2 means it's 2 of those A's. What this 3 means is 3 of those B's. Okay, so just to give this expression a meaning guys, or just to make it simple for anyone to understand, anyone from lower grades to understand. It's more like 2a. It's like 2 apples plus 3 bananas. I'm not sure if it makes sense in terms of 2 apples plus 3 bananas. So it refers to the same thing. It's only that they didn't have to write the whole of those letters. They didn't have to write 2 apples. They didn't have to write 2 bananas. They just wrote 2a plus 3b. But you know, a could represent something else. It doesn't necessarily mean that a at all times refers to apples. You can just choose to make use of fruits so that you give these letters a meaning. And then b could represent something else. It doesn't necessarily mean that b at all times refers to a banana. So I'm not sure if you are actually having an understanding of what I'm trying to explain to you guys. So I would advise you to just indicate by commenting in case if you've got a suggestion, a comment, or a question. So I will surely respond to those comments. So guys, now I just want to explain to you something of which only grade 10s, 11 and 12s can relate. But for everyone in the lower grades, it's for you to just know. You'll be lucky if you understand. So normally in maths, what we usually do is to simplify and solve. These are the main things that we do in mathematics. You simplify or you solve. So you can only simplify when you are given an expression. I'll just write it down. You can also note it down as part of your notes. An expression, and you then solve when you've got an equation. So I'll write it down, equation. Okay, so an expression, how do you see an expression? An expression is just a math related expression without an equal sign, and the moment it has an equal sign, it becomes an equation. I'll just give 2 examples. Let's say you've got 2, I'll just use a different letter, 2p plus 4p, it's equals to, let me say 0. Okay, and the next one I can see I think, let me use k. Okay, let's say 3k minus 1k plus 7k. Okay, so what I want you guys to notice is that you've got an equal sign there, and on this expression you don't have an equal sign. Okay, so this is what we call an equation. Why is it an equation? It's because it has an equal sign. Okay, so for the fact that it has an equal sign, it makes it an equation. So if you can have a look at this given expression, it doesn't have an equal sign. It therefore means it's an expression. Okay, so when you have an expression, you simplify. When you have an equation, you solve. So just note that information. Can either note it down or just always remember that information. So I'm just going to quickly give you 2 scenarios where we simplify and again where we solve, so that you are able to differentiate between the 2. So let's say we have 3, let's say b plus 7b b minus 4b. Okay, so a question that I would actually pose to you is that, is this an expression or an equation? So you just have a look at this given mathematical expression. Can you see an equal sign? No. Then it means it's an expression. Okay, so if it's an expression, it means you simplify, you don't solve. So what does simplification mean? So simplification, guys, it means you write this given expression in its simplest form. Okay, so when you write this in its simplest form, I think, let me give you this quickly. It's more like you've got two. No, let me use an example which is related to that. Let's say you've got 3 plus 7 minus 4. This is what you are given, guys. So I'll just ask myself this question: is this an equation or expression? It's an expression. Why? Because it doesn't have an equal sign. And most importantly, how many terms have I got? I've got 1, 2, 3 terms. Why? I can see they are separated by those signs. So I've got a positive sign, I've got a negative sign, so that means I've got 1, 2, 3 terms. Okay, so because this is an expression, it means I can simplify the whole of this. How do you simplify? Can you punch on a calculator 3? Yes. Can you punch on a calculator 7? Yes. Can you punch on a calculator 4? Yes. So that means you can only punch numbers on a calculator. But if it's numbers which are combined or mixed with letters, you cannot punch them on a calculator, because a calculator only gives you an opportunity to punch in the numbers only. So guys, since this is an expression, can I write this in the simplest form? The answer to that question is yes. So let's see. If you say 3, you can just pull out your calculator and say 3 plus 7 minus 4. It's equals to 6. Okay, it's equals to 6. So I've simplified this long expression to the smallest or to the simplest expression. So that means the whole of this, it's equals to 6, or the whole of this is the same as 6. Okay, so now let's try to work out that expression that I've given to you. So now you've got 3b plus 7b minus 4b. I think I've already answered that question. It's an expression. And again, can I punch 3b on a calculator? No. Why? Because of that letter. On a calculator, I haven't got the letters. So 7b, can I punch that? No. 4b, can I punch it? No. So I assume at this stage you fully understand that you cannot punch all of this on a calculator because it has the letters. Can you see? So that means you can only punch on a calculator the numbers. So now let's try to simplify this expression. So remember, guys, just to make it simple, so it's more like you've got 3 bananas, okay, plus 7 bananas, okay, minus 4 bananas. So let's simplify. So guys, it's like you've got 3 plus 7 bananas. How many bananas have you got? You've got 10 bananas. Remember, you still have that minus 4 bananas. Okay, so it's more like you've only worked out those two. You just added these two. So you shouldn't forget that you have minus 4 bananas. So I've got 10 bananas. I'm now subtracting 4 bananas. How many bananas am I remaining with? So you are remaining with 6 bananas. Can you see? So if you give these letters a meaning, then that's when I think it becomes easy to even understand. It becomes easy to solve or interpret. If we didn't have to use the word bananas, we know it's 3b plus 7b minus 4b. So that means I've got b, 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 then I can work them together because it's the same letters. So that means I've got 3 plus 7 b, which is 10b, minus that 4b, which is equals to 10b minus 4b. It's equals to 4b. Okay, so this is how you would solve that expression if it's given to you. But then as a parent, if you want to make it a bit more easier for your children in the lower grades, you can just give those letters a relevant meaning. Okay, so now guys, let's get to a stage where we solve. So let me just choose, let me use x. So let's say you've got a 2x, let's say it's equals to 4. Okay, so guys, this is an equation. Why? Because it has an equal sign. They're saying 2x, it's equals to 4. Okay, so when you have an equation, you solve. What are you solving, guys? You solve for the unknown. What is the unknown? Guys, from this equation, what is the unknown? You know this is 2, you know this is 4, this is an equal sign. So do you know what is the value of that x value? That's what we don't know. So when we say we solve for x, we solve for that x, which is the unknown in this case. We want to know what is the value of that x. That's why we have something called solve for x. So I just chose to use x. I could have used A, I could have used B, C, D, E, F, G up to Z. So they can just pick up any letter for you to solve. But in most cases, they choose x. Okay, so guys, I'll show you how to solve for x. So remember we had 2x, which is equals to 4. Okay, so that means we want to know what number, when you multiply it by 2, will be equals to 4. That's how you interpret an equation. So it's more like they're asking you what number, when multiplied by 2, will be equals to 4. Okay, so we know that if we multiply 2 by 2, it's going to be 4. But because you might find that this question is allocated 3 marks, you won't just say x is equals to 2, because you just know that when you multiply 2 by 2, it gives you 4. You have to use mathematical rules to provide or to show all the steps. You need to use those basic rules to show how you got that 2. That's how you score maximum marks. Okay, because if you just write 2, it's more like you copied that answer from a friend next to you. That's why I want to emphasize those rules so that you fully understand, and then in that way you'll be able to apply those rules to solve mathematical equations. So remember guys, it's 2 which is equals to 4. So what you do, you want to remove that 2, you divide by 2 on both sides, so that 2 divided by 2 is just 1x, which is equals to 4 divided by 2 is equals to 2. So this is how you score full marks if this question was given 3 marks. So what I want to do now is to also give you another equation of which I think it will be interesting. Let's say 3 plus y, it's equals to 5. So guys, what is this? Is it an expression? Is it an equation? So guys, because of it has an equal sign, it means it's an equation. Okay, so since it's an equation, what do? Do I simplify or do I solve? In this case, you solve. what are we solving? You solve for the unknown, which is y in this case. So guys, this is an equation where they are asking you what number, when you add it with 3, it will be equals to 5. So before you start solving any equation, guys, just try to make sure that you understand what is expected of you. So they are saying 3 plus what number will give you 5. Do you know what is that number, guys? We obviously know. What is it that when you add with 3, it gives you 5? We obviously know that when you add 2 and 3, they give you 5. Okay, that we know. So guys, you don't just say 2, because it's not at all the times where an equation will be this simple. So that's why we need to teach you the basic rules that you must apply to show that the unknown for this equation is 2. Okay, so remember, this is why I just made a question mark, so that I explained to you that they're asking which number, when you add it with 3, will give you 5. So guys, we are solving y because y is the unknown. So it's more like at all times when we solve for a particular letter, which could be A, B, C, D, or Z. In this case, we just chose y. It could have been R, Q, P, any letter. Okay, so now guys, to solve this equation, it's y, it's equals to 5, and then you move that number to the other side of the equal sign. So because you're writing it on the other side of the equal sign, you write it in the opposite sign. So this is 3, it's more like it's positive 3. So the opposite sign of a positive, it's negative. So it becomes negative 3. So it's more like, can you see, you can punch that on a calculator because it's only numbers. So it's more like 5 minus 3, you know, it's equals to 2. So a grade 8, I think, a grade 8, 9, and 10 should be able to know these basic rules for solving math-related equations. But for me to be able to show you how to solve for x, I'll need to then do a separate video for that lesson. But in this case, I just wanted to show you guys what those basic rules mean, because at all times we use those basic rules to approach math-related equations. It could be for grade 10, 11, and 12. Even when you get to tertiary level, at all times you use those basic rules. You get to a stage where you just know how to solve a particular maths equation, but forgetting that you are actually applying these basic rules. So I can tell you now, guys, if you want your children to be good in maths, please make sure they fully understand the basic rules. You don't have to wait until they get to grade 11 or grade 12 and start assisting them with maths related equations, because by that time they would have lost interest in maths completely, because they don't know the basic rules. It's like after being born, they just teach you how to run. You know what I mean? So the best thing that you can do to a newborn is to teach them those baby steps, is to teach them how to walk. That's why you know, the toys that you buy for a newborn are different from the toys that you buy for an adult. So that means you need to know that for a grade 10, this is the toys that they must use when playing. They shouldn't be doing anything complicated, because it's going to demotivate them. And once you try to do something that you don't even know where to start, you will obviously be demotivated. You won't even have interest to go further. But when you start with something that you can understand, that you can interpret, and you do it over and over again until you feel like at any point in time, if they wake you up in the middle of the night and give you one of the rules to interpret, you can easily do that. that's when you'll develop an interest to do even more complicated equations. So that's why I'm saying, guys, it's very, very much important that you emphasize to your children these basic rules. They just need to know these basic rules and everything will follow. So you don't have to stress about assisting them with those complicated maths equations, because you can still explain to them. But I can promise you, even if you are the best in explaining, they will just fully understand what you just explained to them. But try give them a different equation which is related to what you've just explained to them. They won't even know where is the starting point, because they don't know the basic rules. They will see whatever that you give them as a different or a completely different equation, whereas it's the same. You just know that they just need to apply the same rules but differently. So guys, I want to emphasize that the basic rules is the starting point. Okay, so now I will go through each of these rules using different examples. For instance, there it's a to the power 0. It could have been any letter, guys. I just chose a. So remember, at all times these letters, they represent a number. Okay, so that a it could be 7. Okay, so remember, it's a to the power 0. So let's say it's 7 to the power 0. What does it mean? It means 7 to the power 0, guys, it's equals to 1. That means on your calculator, if you can punch 2 to the power 0 and say it's equals to, it will be 1. If you can punch 194 to the exponent 0, it will be equals to 1. If you can punch 1000 to the power 0, guys, it will still be equals to 1. So that means any number to the power 0, it's equals to 1. I'm not sure if you understand, guys. It's not just any number, but still, even with the letters, if you are given an equation where you get to a point, let's say it's let's say z to the exponent 2 minus 2. This is the same as z to the power 0. Why? Because 2 minus 2 is equals to 0. So guys, z to the power 0 is equals to 1. Why? Because anything to the exponent 0 is equals to 1. So in that way, I can say I'm done with the first rule. Okay, so remember, guys, for the purpose of this lesson, it's not really to form equations where I show you how to apply those rules. I will have to make another special lesson where I show you how to apply those rules. For now, I'm just trying to indicate to you what those rules mean. So now let's move to rule number 2. It says a to the power 1 is equals to a. So what does it mean? It means any number, guys, any number or any letter to the exponent or to the power 1, it's equals to that same number or that same letter. Let's say z to the exponent 1, it's equals to, it will just be z. So to make it even much easier, on your calculator, just punch 4 to the exponent 1. So what I'm saying is this will be equals to 4. Can you see? In this case, that a is represented by a number which is 4. Okay, so what it means, guys, it's 17 to the exponent 1, it's equals to 17. Can you see? A to the power 1, it's equals to a. So in short, they are saying this letter to the power 1, it will be equal to that same letter. So it could have been a h to the power 1, it was going to be equals to h. So that's what it means by that rule number 2. Okay, so let's move to rule number 3. So rule number 3, you've got a to the power m multiplied by a to the power n. They say it's equals to a to the power m plus n. Okay, so let's maybe make use of numbers. So guys, it's more like they are saying 2 to the power, for example, 2 multiplied by 2 to the power, let's say 3. Okay, so guys, please notice that this is a, this is a. So that means these two must be the same, because there it's a, here it's a, okay? And the exponent, because this is m and this is n, then it means it could be different exponents. So that's how you interpret those rules. That's why they used different letters there. So in short, it's more like a formula, guys. It's more like a formula, okay? So 2 times to the exponent 2 times 2 to the exponent 3, they are saying is the same as 2 to the exponent 2 plus 3. I'm not sure if you are able to see, guys. A to the exponent m, our m is 2, our n is 3. It's equals to this a, okay? So it means it has to be 2 there, it has to be 2 there. If I chose to use 7, it was going to be 7 there, 7 there, 7 there. So on your calculator, guys, punch this and check what answer you get. And again, punch this and check if you get the same answer. I can tell you now that you will find the same answer. So remember, guys, this is where the simplification part comes in. Can you see 2 plus 3 is the same as 5, isn't it? So that means this thing is the same as 5. So that means if you punch 2 to the exponent 2 times 2 to the exponent 3, you will get an answer which will be the same as 2 to the power 2 plus 3, which will be the same as 2 to the power 5. Let's just quickly do it so that with the other rules that you'll be punching on calculator, you should expect to find the same answer. Pull out your calculator. I'm not sure if you are able to see. So it's 2. This is where you find exponent. You can say times 2. Use this arrow so that the multiplication is down there, not at the top. And you say 2. You say to the exponent 3. Okay. So this is 32. Can you see? So the answer that we get when we punch this is 32. So what I'm saying is when we punch 2 to the power 2 plus 3, we should still get 32. So let's see. It's 2. I'm not sure if you're able to see. So it's 2 to the exponent 2 plus 3. Remember, guys, that positive sign is at the top. So it's 2 to the exponent 2 plus 3. Let's see. Can you see? We get 32. So it's 32. Let's see when we punch this. So it's 2 to the exponent 5. We must get 32. Can you see? It's 32. Okay. So guys, just so that you are able to understand if you are in grade 11 and 12, and again if you are doing if you are upgrading some of the modules. So what they normally do is to take a lot of terms, or they use these letters to combine these letters in different ways, such that they want you to just apply all of these different rules. So that's how you actually solve those equations. No matter how long or how complicated the equation is, you always apply those basic rules. So that's why I'm saying it's very, very much important that you understand those rules. Okay, so guys, rule number 4, it's a to the exponent m over a to the exponent n. Okay, they're saying is the same as a to the exponent m minus n. So what it means, guys, sorry, let's say our a, in this case, let's say it's 8. So it's more like it's 8 exponent, let's maybe use 4 over, I cannot use a different letter because they used the same letter, I mean a different number, so they use the same number. So that means 8 represents a. Wherever I see a, I use 8. So I use 8 there, and then n, I can use any number, let's say 2. So what they are saying, guys, is that because you have 8 to the power something over 8 to the power something, so instead of having to write this 8, you can just have 8, then you subtract the exponents. Okay, so that's what that rule means. So guys, 4 minus 2 can be simplified. So you've got 8 to the exponent 4 minus 2 is the same as 2. Same thing that we did. You can just punch all of these, all of these, all of this. When you punch that on a calculator, you will get the same answer. So guys, if I'm moving too fast, if you've got any questions, please do drop a question in the comment section. I'll attend to those questions. So now let's move to rule number 5. So rule number 5, guys, it's a to the exponent m to the exponent n. It's equals to a to the exponent m multiplied by n. So let me use, in this case, 4 as a. So it's more like into, you have 4, let's say to the exponent is 2, you close, maybe let me use 9. Okay, so what it means, guys, is that instead of you having this with the brackets, this thing is the same as 4, you just multiply this 2. Okay, so it's 2 times 9. Okay, so if you can see, guys, everything on the left is represented on the right. So you've got 4 to the power 2 into times to the power 9. So it's the same 4, it's the same 2, is the same 9, just like you had a m m n n. Okay, so for now, guys, you don't have to stress that much. You just need to know or understand what I'm explaining to you. So I will make sure to notify you when I've got another lesson where I bring equations from past exam papers and show you how to apply these basic rules. So without these basic rules, you won't confidently understand maths, because from question 1 up until the last question, you will be solving in maths. And these are the basic rules that you apply. It doesn't matter whether you're calculating areas, it doesn't matter whether you are doing that chapter for functions, whatever that you do, guys, in every question, the moment you see yourself taking a calculator, just know it's either you're simplifying or you're solving. And in order to solve or simplify, you use or you apply these basic rules. Okay, so now let's get to rule number 6. Rule number 6 says a over b to the exponent m, it's equals to a to the exponent m over b to the exponent m. Okay, can you see, guys? Don't confuse this with maybe a rule number 4. Okay, so what it means, guys, is that this, because this is the exponent, you remove these brackets by powering all these letters a and b. Can you see? So it's more like, let's say our a, which letter did I not use? Let's say it's 5 over, let's say, 7. Okay, into, let me use maybe let's say 3. Okay, so what it means, guys, it's equals to, so all of this information must be represented on the right side. So our a, in this case, it's 5. So it's more like you've got 5 and then you power it by 3. You've got 7, you power it by 7. By 3. Can you see? So guys, this equation or this part, it's almost the same as that one, isn't it? But you cannot say you see, I'm even failing to do it. You cannot say maybe 5 to the exponent 3 minus 3. Why? It's because your bases are not the same. Okay, I think you do understand that part, which is rule number 6. So guys, I just remember that I need to mention something to you so that we use maths language. So for example, a to the power m. So guys, this is the box for a, this is the box for the power. So we call this power, or you can call it exponent. Okay, and we call this number a base. So at all times, just know that when you have maybe x to the power 2, this is the exponent, this is the base. If you have y to the power z, this is the base, this is the exponent. When you have 4 to the power x, this is the base, this is the exponent or the power. So at all times, you should be able to identify your power. You should be able to differentiate between the power and the exponent. In that way, you'll be able to easily interpret these basic rules. So in this case, this is the base, power, this is the base power, base power, base power, base, the whole of this, it's power. So maybe s to the exponent y minus 1. This is the base, and the whole of this is the exponent. Why? Because it's written at the top of your base. Okay, so you can have something like maybe y to the power 2 minus y plus a z. So this is the base, the whole of this is the exponent, this is the base, the exponent in this case, if nothing is written, then it means it's 1. Okay, so if it's 1, that's why they just write it z. Why? Because if it's a to the power 1 is the same as the base. So guys, as I've said, you don't need to worry much. Just know what I've explained to you so far. So now let's get to the last rule, which is rule number 7. So they say a to the exponent negative m, it's 1 over a to the power m. I wanted to get to this stage so that I'm able to explain to you the difference between a minus and a negative. Can you see, guys? This is a minus and a negative. They do almost, they perform the same function, almost the same function, but they are used to represent these numbers and letters in a different way. For example, guys, this is a negative. Okay, so they are saying a to the power negative m is equals to 1 over a to the power m. Can you see? So if we had z to the power negative y, then it means it's 1 over z to the power y. It's more like we rewrite the whole of this with a positive power. So for you to write it with a positive power, then it's 1 over whatever that it is, but in a positive power. Okay, so what I wanted to explain to you guys in terms of the difference between minus and negative, it's because you can be given something like x minus 2, it's equals to 4. Okay, so this is minus, guys. If you're given something like negative x minus 2, it's equals to 4. So this is a negative. Can you see? If it's not connected to anything on the left side of it, then it becomes negative x. Then this is minus x, it's equals to 4. So you can have maybe negative y minus y, it's equals to 4. Okay, so guys, can you see both of these are the same, right? But we call them differently. So this will be negative y minus y. Okay, why? Because this first y, it's not connected to anything. It is therefore negative y. Then we say minus y, it's equals to 4. So that one, it means it's positive x. We just say it's x plus 2. If it was a plus there, then it means it's positive x plus 2, which is equals to 4. Okay, so that means we have a positive, we also have a negative. So this is minus and this is a plus sign. Okay, so guys, I hope at this stage you fully understand this basic rules. So I'm not sure if there's something that I'm missing, guys, but I think I've explained everything that I wanted to explain. So on my next lesson, what I'm going to do is to bring equations where I solve those equations by applying these basic rules. So I would encourage you guys just to please do subscribe and hit the bell notification so that you're notified when I upload that lesson. And again, please just do give me a feedback to explain if I was too fast, if this lesson wasn't straightforward, if it wasn't clear. Otherwise, if you understood everything, it was simple, please do give me those comments, because I rely on your feedback to improve for future uploads. So guys, thanks very much. My name is Desmond and I'm out.